Hi everyone, my name is Ronald Jogaib, and in this video we will do a demonstration about digital twin. Here we are using the digital twin in left. I can show to you the digital twin of Siemens Siprotec. This digital twin is possible to virtualization this relay protection, and this protection it is a bus bar protection, and we are using two the digital twin of Omicron. This is the software relay syntax of Omicron, and in this version, it's possible to integrate the digital twin of Omicron with digital twin Siemens. So we want a demonstration to you the powerful of these two tools in an example. This example of bus bar protection that we are testing is, for example, if we construction a new bay in this kind, it will be this bay, dx. And for example, if you want to know if my configuration in my bus bar protection it's correctly, and all the settings and the logic will to be correct, we can do a simulation with just two softwares and validation the new settings and the new logic. So in the backup of this relay, we put a new logic and a new settings because we receive a new bay. So how can I test this? Usually you have to go to a manufacturer, or you have to put the relay in some place to test and connect a lot of wiring. And for sure, to simulate the equipment is very not expensive, but it will take so much time to do this. And with these two software, it's possible to do the connection virtually. So we didn't spend time doing these things. For example, in the Omicron relay syntax, you can see here, for example, in this suite or in this connect or in this secret breaker that we configure the contact of this equipment. So we can go here. Sorry, it's not here. What it's possible to do? You have to draw all your base and your all disconnector and secret breaker. And what I have done here, I put some merge units or bay units. You can call what you want, and we connect all this equipment to this relay. So uh, what I'm showing to you here, for example, if you do a double click here, we can see what the equipment they are monitoring. For example, here it's all the equipments that this bay unit, for example, is monitoring, and we can see what this bay unit see. The current, for example, I put a CT to take the currents of the all phases here, and I put one CT to take the neutral currents. Here I put my circuit breaker with a trip contact. So for example, this is a contact that my bay unit will do in this circuit breaker. So if I do a trip command, the circuit breaker will open. I put this close command, but I didn't use this close command because I just simulate my bus bar protection. And here, for example, is very important. We can see all the binary inputs that I want configurator. For example, if I want to simulate my secret breaker with the contact A and B. So this is a contact of close my secret breaker. When this contact it's in when my secret breaker is closer, this contact is closer. So this logic they will give me a binary input with 1, for example. And if my circuit breaker operates, this will be 0. This is the same thing, but the contact B of the circuit breaker and to disconnector. So for all bay units, for all bay that we have, we configured this. So all these bay units, for example, this bay unit is relative to this bay, that it's a CX, and we are monitoring all this equipment. Okay. So what's important? I want to show something is very good too. I will do more details about this to demonstration particular things that you have in this bird protection. But for example, in this circuit breaker, we can configure the time of the trip, the time of the closer, and we can configure, for example, a time between the current that will flow and the contact. For example, here is the circuit breaker open. Depend of the value of the current, for example, a high current, probably your contact of closed circuit breaker will be go to 0, but the current still flow in the circuit breaker. So we can do this in this simulation. For example, we can see percentually or in the time absolutely. Okay, I will show a demonstration about this, but I just want to talk to you. So what I can do with these two power tools? I will demonstration in this case. So I have configured my relay protection in digital twin of Siemens. What's important? When you do, for example, I have this simulation here that I put that is a stable load flow. And just to understand, Omicron give to us an example of this. So I just changed some things to my particular installation. So here we have the case of a stability flow. So we can see the current that this all this source will do here. For example, I can change the angle of the source. So my source in some case are inject current and the other source here it's receive powerful. So all the things it's possible to see here. For example, my bay of AY, this current is with this angle, -7. And for example, my bay CX is in the same angle. So we can conclude that this current is in the same flow of these two bays. And this bay dx it's a positive in 108. So this current is in opposite side of this. Okay. And what I want to do here, in this case, I don't have fault in my protection, and I don't have fault in my bus bar, and I have here all this equipment closed, and we can see, for example, I will give it just a little zoom here. We can see that this bay is connected to the bus bar 1. This bay is connected to in the bus bar 1. This bay, the new bay in bus bar 1. My secret bay that connect the two bus bar, it's closer, and this other bay it's connect to the bus bar 2. Here I will do a simulation with no fault in the bus bar, and I put the time of the simulation in 60 seconds just to show how the software is integrated with this other software of Siemens. First, I want to show something here. For example, I turn on my relay yet, so this is is doing a simulation of my relay. For example, what is incredible in this software? I did a VPN client to connect this software that I use running in a web. I do a VPN client to connect to my computer. And here, for example, I was with my settings of this relay, and it's possible to connect to this relay to see the response of this relay, for example. So I'm in the online of the relay in indication, and if I do, for example, a command to clear all my LED, I can see this command in the software because this software is connected with this virtual relay. Okay, just to show you. And what I want to do, want to show you, when we do a simulation, for example, and relay syntax, I will put play here. The simulation didn't start yet, but this step is a step that you have to create a .xml file. And this file, you don't have to change the name. It's a API reference. When you created this file, all the equipment and the current that you have in your systems is exported to a .xml station. And in the Siprotec digital twin, what you can do, you can import it. For example, I have already done this imported IP reference file. So here I can do this. So why you do this? Because here in the root metrics, you can connect all these binaries inputs or binaries outputs or current to my relay. For example, I will show a API reference. This is my source, and I put this in my destination. So, for example, this destination is a isolator of my bay IY, and I connect what I have connected here. I can show to you. I will see what the name disconnected AY1. So I click here. I can see this is the isolator. Okay. I will click here in my bay unity Y IY. It's the same B unity here, the name. And I will click here. Sorry, double click. Not here, sorry. This is in the power system that we created it. So we did a double click here. Not here, sorry again. You come here in the bay unit. And we can see, for example, my binary input. And in this case is the isolator AY. And I connect this connector, this contact here. So in my bus bar configurator, you can see the name of the binary input in my relay, because here is my source, that is the IP reference, that is this one, and here is my destination. So all the equipment is integrated with my relay protection, okay? And we can do this for what? For the current, for sure. So I connect all my CT currents in the channel, in the analogic channel of my relay. And we can do the opposite way. For example, let me show you. I put a binary, and I want to take the trip of my protection to open my circuit breaker that is in relay test. So I put my source, now it's my relay, and now my destination is API reference. So here you can see what's this. This is the binary output of my relay, and this is a trip binary output, and I connect to what? To my circuit breaker CBIY. So when this contact close of my relay, I will open this circuit breaker. So this is a good integration, and I do just a little demonstration on how to work. I will not do this integration with you. You can see in other videos of Omicron how to do this. But I want to show to you what the benefits, the powerful of this tool, for example. So I will go again to my simulation, to my case that it's a stable load flow. So here, I just wanna show to you that I did all the connection correctly. So I wanna do the play of the simulation with 60 seconds, and I wanna see if all my equipment in the relay will be response like this one to have certain that I do all things correctly. So what is better to see in my relay in this case of Siemens relay? I will put my screen here and I will open with you the single line configuration of my relay. So I give a double click here. Okay, I didn't start yet my simulation. So for example, I will do a zoom here. You can see all my equipment, it's not connected. I'm lost the connection. Why? Because I didn't start the simulation. So I will do the play here and you can see all the equipment. You will change this kind of line. Okay. So let's see. I'll do a play. Okay. I in the past I imported this API in the digital twin of Siemens, and I forgot it's necessary to take the API password here. Okay, so let's go continue. You have to see that the software relay syntax calculate the signal. They will update the signal. This is a big simulation, so take a little more time. And now you have to wait. This execution with digital twin will start. Just more a little time. They started. I put more time just to see. You have to wait a little, but now you can see my equipment. For example, this B, I put this in the bus bar 2. This is AX. You can see my AX, my circuit breaker is closed. So here you can see my circuit breaker, sorry. So I did the simulation. I can see the current of all my bay here that I'm applying here. So I can see the systems is equal of this one. So all my simulation or all my integration with this software is correctly. So I did put some more time to see that I don't have a differential correction current in my bus protection, and now I stop to do the simulation here, and probably here it will be stop again, and now I lost my communication. So okay, everything that I connect is correctly. So for example, if I want to start, I want to test if I do a trip in this bus bar protection with my new settings in my relay, and I want to know if all logic and setting is correct, what I can do, what we can do, we can go here in bus bar fault. So here, what I have done, for example, we created steps of test. For example, these first steps, you can see it starting in 0 second and go probably here in this time that you can click here and you will see delay size at previous events 500 milliseconds. So these other steps, what I have done here, I apply a fault in bus bar 1 here. So what I want to test here, I want to see when I do a fault just in bus bar 1, if just the bay that is connected to bus bar 1 will trip. So in this simulation, I will expect just the circuit breaker open. This one, and this one. And for sure, the circuit breaker that connect the two bus bar. And I hope this circuit breaker not open. So I want to test if I implement, if I put this logic and sets correctly in my relay. So I have to play this and just to see the interaction of these two equipment. And like I said to you, I can see all the indications of my relay in online. So I will clear because this is an indication that we have done just to put the loadable without fault. So now let's do the integration. And now this simulation, it's just a little more fast because we just put in a 700 milliseconds. So let's play the simulation. Okay. So like I said, calculation sign, update sign. Oh, wow. Now it's very fast. Sorry, I interrupted here. I will close here. Just no one interrupt me. So what I have done here, you can see the response of the relay syntax, and we can see the steps. And this is very good to see because here the relay syntax created another step. I can say this because was the fault, and this fault was clear, and they showed here the consequence to clear here. And what you can see here, all the circuit breaker that it was open by my bus bar protection here, and just the bay that it was connected to the bus bar 1 open. So here we can say my selective and my logic and my settings put in this relay is correct. So we can validate this with a easily way to do. And here, this is all the events that we have in the relay. For example, I apply a fault here in this time, 500. So here, relative time, we can see it's 0. So if I put in this, for example, we can see that we have a bus bar protection check zone. Okay, we have a bus bar protection operated, and here you have a trip of a bus bar protection 1 phase A. And here you have all this close command, sorry, the trip command in my circuit breaker. So it's very easy and very simple to do this test. Okay, okay. So now what I want to show to you, I want to show if I change a big connection to other bus bar protection, I can test this one. So let's do this. I will clear this event, and now we change this bay and we will put this bay. I have to clear the results or results. Now I will change this bay and put this bay in bus bar protection 2, and I just give default in bus bar 1. So let's do the play. Now I expected that this bay not open. So start calculation, update signal, execute signal. And here we can see the binary output that is integrated to my circuit breaker. For example, we can see in this step that I just give the trip in this bay AY, BY, and CGL. For sure, if I click here, we can see just this base, it was open. So very good, and we can see the selective of bus bar protection, it's operated. Now I want to change a little bit more just to show the powerful of these two tools. Okay, so let's go here. For example, in this case, I have what I put in this case the name close CX info. Okay, so I click here. What I want to show to you guys here, I want to show that I will give a fault in in the out of zone of this bus bar protection. So this fault in this base is not inside of my bus bar protection zone. It's out of sight. And I want to know how this bay will see this fault. But I want to show something that is very important to you pay attention in the relay bus bar protection of Siemens 7SS85. Okay. In this case, what I have done in these settings of bus bar protection, I want to show to you here. In this case, I will show one settings that important here. So for example, my base is CX. So I will open my base CX. I will open my circuit breaker, and I want to show to you that I have a anti-fault protection enabled in this protection. And we put a fake value just to enable this protection. And what is important in the relay of Siemens? When you enable this protection, the bus bar protection 7SS85 will see state, the status of my circuit breaker to see if you can put or not put the current of this bay in the differential current of the protection. So for example, if my circuit breaker is open, the bus bar protection will not consider this current that is flowing here. But if my circuit breaker is closer, they will take this current in GCTs and put in the sum to have the result of the differential current. And why this is important? This is important for kind of fault that we have in what place I will show here is the famous blind spot and fault protection. That is a fault that you can have between the circuit breaker and the CT. And for example, what happens in this case? If I have this kind of fault and all my base is closed, this is the protection bar zone, and probably this fault will not be clear because we have to we have current flow from this bay. So we have the logic of end fault protection to give a transfer trip to remote bus. to the remoted substation here. But what is important and why is important my bus bar protection to see the status of the connector, the status of the circuit breaker, to know to put in or out the current of my bay. For example, if this bay is aligned and for example this line is turned out of, it's in out of service, and I will put this line in service, and I will start to energize this line in the remote terminal. Okay, so for example, if my maintenance forgot the circuit breaker, this pole of the circuit breaker in grounded, so I have a fault here. And for example, if I put my circuit breaker open, so I'm in this case, for example, and I have a fault here, so between the CTs and my circuit breaker. When I energize the terminal remoted, I have a current that will be flow to these CTs. And probably I have a protection in the line remoted, in the terminal remote, that is a switch on to fault will be operated and clear this fault. But if my bus bar protection didn't see the status of the circuit breaker to put in or not to put the current, what will happen? So the circuit breaker is open, but my bus bar protection is not seeing the status of the circuit breaker. So what will happen here? I have a current that you see in this CT, and my bus bar protection will put this current in the sum of the differential protection. And my bus bar protection will operate, and this circuit breaker it was open, and we clear the fault with the soft, for example, that operated in the terminal remote. So we have a bus bar protection incorrectly operated because it's not necessary to open this all circuit breaker for this kind of fault that I said to you, because my circuit breaker it was open. Okay, I will show this demonstration to you. But one thing I wanna say first that's important. When you put the end flow protection inherent of the bus bar protection enable, what is very important to you setting in your bus bar protection? Two things. You have to put the signal of the close command and the automatic reclose of this bay. And for sure, you have to put a delay to when you open this circuit breaker. Why this is important? For example, if I have a external fault of the zone of my bus bar protection, so we have a fault here, and it's a permanent fault. So we have a fault here, and probably my line protection will be operated. So we'll open the circuit breaker. Okay. And we have a reclose in this line, automatically reclose. When we do automatically reclose in the fault, we will have a high current, and probably your bus bar protection will see what? We will see first the current flowing in GCT, and after you will see the status of the circuit breaker. So in this case, you have an incorrect operation of the bus bar protection when you close or you do a automatic reclose of this bay in a fault. So the signal of close command manual or auto automatically reclose is important to be put in the signal of the protection. Why? Because you take the signal and you put like this. Please, bus bar protection, see this current when you do a close command or when you do a reclose, automatically reclose. So in this example that I give to you, I will have a fault. When you do a command to close here, I have already done this bay in the sum of the differential protection. So what I have done here? First, I will show to you a simulation without the command of my bay. And I want to show in this simulation that I will have an incorrect operation of my bus bar protection in a fault that it wasn't in the zone of the bus. So this is the example. Close C else. Okay. So what's this is the step that we have. This first step is just the circuit breaker open. This is another step. I give the fault here, but I didn't close. So not you don't have current flowing this here. And the second step, it's what the third step, sorry, is the close of this bay. And now we have current because you close here. And probably what we expected here. We have the incorrect operation of this protection. So I will show to you this simulation here, okay? Okay. And one thing that I talked to you in the first time that is important to configure the contact auxiliary of the circuit breaker in response of the current that will flow here. So what I have do here, I go in the power system, I will show to you the circuit breaker, I will show the configuration of the circuit breaker. Sorry, first I have to enable editing and clear our results. Okay. So what I have done here, I put the time of my secret close time, I put 8 milliseconds, and you can see the configuration of the circuit breaker closed. This is a contact that will be in 1 when my circuit breaker is open. So here I stop to see my circuit breaker open, but I put my current flow in the circuit breaker to start first. So in this interval, we have a current with a circuit breaker open. And this is very common to happen in the when you close a bay in fault because to flow the current, it's not necessary to have the contact closed. And for sure, the contact auxiliary has another time to response. And what's incredible, we can see this time that we have. First, I didn't do the simulation, so I just want to show the response of our contact auxiliary of the circuit breaker and the current that will flow in this bay. So for example, I put the two signals here together. I will give a zoom and I will take here. For example, you can see that my current in my bay CX start here, but my circuit breaker will be with the contact say that they are close just here. What time you have the interval time that we have between here? Just 50 milliseconds. This is very common to happen, and this is not a big time. I can say that is a very small time, and it's happen when you close this in default. So let's have done this simulation here. Okay, I will close. I will show the indication of my protection, and I will start the simulation now. This base is connected in bus bar 1, this base in bus bar 1, this one in bus bar 1, and this in bus bar 2. So I apply this fault, and probably when we close in, in, in a fault, they operated this bus bar protection. So let's do the play here. Sorry, my software, I think they cleared. Oh, I can see these steps. We will go again here again. It's not the simulation, it's the other one. So let's go here. Sorry, I will optimize all here. And now I can go to here. So let's do the simulation. So I did the simulation. You can see now we have the first step, we have the second step, and we have these steps that applying the fault. Okay. And what you have here, you have this strip in this circuit breaker. So we can see here that this fault it was outside the zone of my bus bar protection, but my bus bar protection operated incorrectly because I said to you the interval time that we have about the current that will flow in this fault and the status of the circuit breaker. So here you can see all the events that we have in a bus bar protection. So we can see we have operated the bus bar protection and it was zone 1 trip phase A. Okay, so I show to you a problem when you don't put the signal of close command of here in this bay. Uh, so I want to show to you if I put the close command or a reclose command in this bus bar protection, the bus bar protection have a good operation. So this is the set this simulation that is a close CX in the fault with command. How we can do a command in a relay syntax? Omicron, I will ask to you to do something more easily, okay? But we can use our creative. So I put a circuit breaker here. This is a fake circuit breaker. It was connected in a fictitious bus bar. And what I have done here, this contact of my circuit breaker will be put the signal in my bus bar protection in one, and I interconnect the signal of what? Of the command or the reclose or the automatic reclose in my in bus bar protection. So the circuit breaker is like a command that we can have. And for sure, you can see here that I have to connect the circuit breaker to my uh, bay. I didn't. It's not necessary to connect to my bay unit. Okay, for sure. No, it's necessary. Sorry, it's necessary to connect it here. So I can show to you not here. Probably I have to show here. I'll show here. Sorry. If I give a double click here, we can see that I have renamed this for sure. I wanna see the rename of this. It's not this one. It's not this one. Maybe I wanna remember where I put this connector. It's not here, it's not here. Ah, sorry. I put the circuit breaker in these control units, for example. So here you can see the circuit breaker is linked to this relay. That's a control unit. So you can do a double click here and you can see that what I connect here. I connect my binary input and I give the name that it's a CB close command. And here in Siprotec Digital Twin, I routing my IP reference to my relay protection, my bus bar protection, and I put these two signal what I have done. If I give the close command to my bay CX, we can see that I linked here in this binary input of my busbar protection that is a binary inside of the endflow protection close command. Okay. And what is a fantastic thing that you can see here? If you go to the case that you are simulation, we can see all the contexts here and is very good and easily to understand. For example, so what's what was the step that we created here in this case? We put a step normally, okay, and this secret breaker, fake secret breaker, it's open. This real secret breaker is open too. Here we apply the fault, but this bay it's open, so don't have current flow here. And here we created a command in our secret breaker faker. So I give this command, and this command is looks like a closer command to my bus bar protection. The other step it will be this close command. And to show all these interactive, I will show here. So the first step, you didn't apply the fault. We apply the fault here in the second step with my bay open. And in this third step, I give the close command to my bus bar protection that was linked here. And we can see here the circuit breaker will to be closed because of this step of the simulation. And I put a time between my command and my close command of the circuit breaker. And this time we can set here, for example, I put a delay to the previous event that it was 70 milliseconds. And we have here the same example we do early. So you can see that the time between of the current flow to my bay and the time between my circuit contact close, it is 50 milliseconds. Okay. When you do the simulation without the command, we have the bus bar operated incorrect to this fault that was outside of the zone. So now let's do the simulation with the command. So I will do the play here. I will see the event. Sorry, I didn't clear the event here. I have time. Oh, yes, because I didn't start the simulation. So now we can see what will happen here to our bus bar protection. What is incredible, again, we can see these steps and all the result that we have. Here is the result. The fault stay isn't clear because we didn't represent the protection of the line. For sure, the line will be open the secret breaker, but what is the most important something that we can see? In this case, we didn't have the bus bar operation incorrectly because you put the command. So we can see a very good very good results of our bus bar protection. And here we see the important signal that is a signal that is very important to be configured in our bus bar protection when you enable end fault bus end fault protection. And to enable this protection, is important to have more selective in bus bar protection of SIMs. So to conclude, we see the powerful of these two tools, and we can see that we can test our logic and our settings to a kind of new bay that we have implemented, or we are receiving this new bay to our bus bar protection. And we can see something very good, that it's to change the response of the current flow in the circuit breaker and the contact to see the operation of my bus bar protection in a closed command or in a kind of end flow protection. So we see that in Siemens Protection 7SS85, when you enable the end flow protection of your bay, you have more selective to fault that we can have between the circuit breaker and the circuit breaker and the CT when your circuit breaker is open, because when you enable your bus bar protection, you will not see this current if the circuit breaker is open. And we see when you enable this function, is very important to put the signal of close command manual and for sure the auto reclose. Other thing that is very important is the time of open circuit. For example, I will show here, I didn't do the simulation, but I will explain something that is important for you. So for example, here you can see more. In the case of the open circuit, so for example, if you have a fault outside of the zone of the bus bar protection, we have a high current that will flow in the circuit breaker, and probably you have the same response. For example, your contact will be stopped here. So here we stopped to see the circuit breaker, which was it was closed, and in here the circuit breaker open, but you have a flowing current here. So you can operate it incorrectly in this kind tool. And what is important to configure it in this case, I will show here. Let me see if I can show to you. It's not here. I think it's in the control. Sorry, it's not here. I think it's circuit breaker. Current the show, not here. Circuit breaker, output time, supervision. Sorry, I think it's end full protection and I forgot this. Here, it is settings. Delay CB circuit breaker open. You put 8 milliseconds. Okay, so when the circuit breaker open, our bus bar protection will wait 8 milliseconds to say that the circuit breaker is open. And this is important when you have a high current that will clear by the protection in this line and open the circuit breaker. So I hope you like this kind of tools. I hope you like this video, and I hope all manufacturers that work together with these kind of things, because it help so much our engineers protection. Thank you so much. I hope you see in more video, and I hope you can learn together with this kind of example.